Alright, today we're going to go over E1.3, which is linear equations in one variable, which is pretty much just solving basic equations. Okay? We're going to throw some variables in there, we're going to throw some fractions in there, but other than that, hopefully none of it will terribly offend you. So, alright, first thing we need to know what a linear equation is. A linear equation means basically we have one variable to the first power. Okay? One variable to the first power. Anytime we have linear equations, we're not going to have x squareds and that type of thing. We're just going to have regular x's. Solutions to linear equations, you can have 1, 0, or infinite solutions. Okay? May have 1, 0, or infinite solutions. Okay. Alright, so let's go ahead and look at a couple. First one, we have fractions. Anytime we have fractions, we want to get rid of those denominators. Nobody likes to work with fractions. The way we get rid of those denominators is we multiply every term by the least common denominator. So here, if I look for my least common denominator, it would be 12. So I'm going to go ahead and multiply every single term by 12. So I'm going to do 12 times this piece is equal to 12 times this piece plus 12 times 1. Okay? And the reason I did that is because now notice all of my denominators will cancel out. 4 goes into 12 3 times, which leaves me with 3 times 7x plus 3. My next term, 6 goes into 12 2 times, so I get 2 times x minus 1. And then my third term, nothing cancels out because I didn't have a denominator. So 12 times 1 leaves me with just 12. And then I want to go ahead and finish working it out. I'm going to distribute my 3 and my 2 into those quantities. So 3 times 7x gives me 21x, plus 3 times 3 is 9. 2 times x gives me 2. 2 times negative 1 is negative 2, and then plus 12. And then from here, we're just basically trying to get all of our x's on one side, all of our constants on the other. I'm going to go ahead and combine my x terms on the right-hand side of the equation. Negative 2 and 12 gives me positive 10. And now I can go ahead and start getting all my x's in one spot. Okay, I'm going to move over here just so I have some more room. 21x plus 9 is equal to 2x plus 10. I'm going to subtract 2x from both sides to move my x's to the left, which leaves me with, excuse me, 19x plus 9 is equal to 10. And then I'm going to move my 9 to the other side by subtracting. So I get 19x is equal to 10 minus 9 is 1. And then I just divide off that coefficient, which is 19. Okay. So what I end up with is x is equal to 1 over 19. Okay, easy peasy. Let's look at another one. This one's a little bit nicer because, well, it doesn't have fractions. We are going to go ahead and start off by distributing in this negative 3. A big mistake I see done all the time is people forget to take the sign with it. If it's a negative 3, the negative goes with it. So negative 3 times negative 6x is positive 18x. Negative 3 times positive 8 gives me negative 24. Then I have a minus 5x is equal to 15x minus 1. I combine my like terms on the left, so 18x minus 5x leaves me with 13x minus 24 equals 15x minus 1. And then again, get all my x's on one side, get all my constant terms on the other. So I'm going to subtract 13x from both sides to get all my x's on one side. So I get negative 24 is equal to 2x minus 1, and then I'm going to add 1 to both sides to get that x term isolated, which leaves me with negative 23 on the left-hand side. And then the last thing I do is divide off my coefficient, which is a 2. Okay. In my math lab, most of the time it will tell you to leave your answer as a reduced fraction or a decimal rounded to a certain place. I prefer it be left as a reduced fraction, but if it gives you the option to enter it as a decimal, that's fine. Okay, so here we get x is equal to negative 23 over 2. Okay, let's look at another one. I'm going to look at one more and then I'll have y'all do some. This one, again, has fractions. To get rid of fractions, we multiply every term by the least common denominator. So on this one, my first term's denominator is 5. My second term's denominator is a 1. My third term has a denominator of 10. And my last term has a denominator of 1, which means that my least common denominator for this equation would be 10. So I'm going to multiply every piece by 10. Okay. Notice that first term is all one piece. Because it's being multiplied together, we don't have to multiply 10 to each little individual piece of it. Oops, forgot to multiply by 10. On the right hand side, I'm going to do 10 times the negative 1/10 x plus 10 times 1. Okay. And then all I have to do is reduce my fractions away, just like before. Here, 5 goes into 10 2 times, so I'm left with 2 times the 1 that was on top, which is 2, times that remaining quantity, 2x minus 7. My second term, there's nothing to cancel, so I can go ahead and multiply those together. 10 times 5x gives me 50x. On my next term, my 10's cancel, and I'm left with negative 1x, or just negative x. And then 10 times 1 is 10. And then from here, I'm just going to go ahead and finish working it out. I'm going to distribute my 2, which gives me 4x minus 14 plus 50x is equal to negative x plus 10. I combine my x terms on the left-hand side, which is 4x and 50x, which gives me 54x minus 14 is equal to negative x plus 10. And then I'm going to move my x to the other side. So I add x to both sides, which gives me 55x minus 14 is equal to 10. Then I move my 14 over by adding, which gives me 55x is equal to 24. And then the last thing, excuse me, that I have to do is divide off that 55. And I'm going to go ahead and just come over here to do it. 55x is equal to 24. When I divide off that 55, notice 24 and 55 don't have any common factors, so we're just going to leave it like that. That's as reduced as we're going to get. Okay? All right, so on the next page, there is 2 for y'all to try. I'll give you a minute to work those. Okay, we are going to go ahead and go back over these. Number 1, we needed to distribute the negative on both sides. Once you distribute the negative, you combine the like terms on the right-hand side, which is your 9 and your 7, which gives you 16. Then from there, you move all x's to one side, all constants to the other. Okay? When we do that, we should end up with 21 over 2, and that cannot be reduced. You don't have to make a decimal. You don't have to make it improper. I'm sorry, a mixed number. Just leave it improper. Okay, 21 over 2. On the second one, we need to clear fractions. Our least common denominator in this case is a 6. So when I multiply every single term by 6, notice my denominators cancel out. Don't forget to put parentheses around this piece that's left from the numerator when we cancel. Okay? If we don't put parentheses around it, then sometimes we forget to distribute that 2 to both terms and to distribute that 3 to both terms. Once we've distributed that out, then we go ahead and combine like terms, then collect all our x's on one side, all of our constant terms on the other side, and then just like before, divide off that coefficient, which should leave us with negative 14 over 17. Okay, so I want to look at sort of the same thing, same type of steps in terms of solving equations. The only difference here is we're going to solve formulas, which means we use the same steps, but there's less numbers and more letters. Okay, so this first one says solve P equals 4QT for T. Okay, so that means I want to isolate T. I want to get T all by itself. So I have P is equal to 4QT. Now when all these numbers and letters are written right by each other, side by side, that means we're multiplying. To undo multiplication, we divide. So I'm going to go ahead and just divide off the 2 things I don't need, which is 4 and Q. Okay, so those will cancel, and I end up with T is equal to P over 4Q. Okay, same process, less numbers. Let's look at another one. This next one is r is equal to 2/3 y minus 14, and we're solving for y. So before I can get inside this quantity and solve for y, I need to go ahead and get rid of what's outside the quantity, which is my 2/3. And I can do that by multiplying by the reciprocal. Okay, so I'm going to multiply this side, reciprocal, by 3/2. So I have 3/2 r is equal to 3/2 times 2/3 y minus 14. Now, when I multiply any fraction by its reciprocal, notice that cancels the entire fraction away. So on the left-hand side, I have my 3/2 r, and on the right-hand side, I now just have y minus 14 left. And then to solve for y, it's pretty easy. I just add 14 to both sides. Okay. Now for these sections, it's not really picky on getting common denominators and all that, so I would just write it out the way it's left. Once we solved for y, we ended up with 3/2 r plus 14. Okay. If you want to get a common denominator, you can. I just assume leave it like that. Okay. All right. Let me look at another one, and then I'll have y'all try some. This one's the same idea. The only difference is we're solving for a variable that shows up in the denominator and the numerator. Okay, so just like before, I'm going to solve this one by clearing fractions. Now, I do have this negative in front, so this negative is not being applied to the top and the bottom. Remember, with negatives, you either stick it on the top or the bottom. In other words, negative a over b is the same as a over negative b is the same as negative a over b. Okay, so wherever that negative is, you can either write it out front, you can write it on the top, or you can write it on the bottom, but we don't put that negative on top and bottom. So before we get started, I'm going to go ahead and just distribute that negative to the top. And that way it's not floating out there and we don't have to worry about it. So this gives me y is equal to negative 4x minus 1, all over 3x minus 2. Now, since I'm solving for x, I need x to be out of the denominator, so I'm going to multiply both sides by 3x minus 2 so that I can cancel that on the right-hand side. Those will cancel. And what I'm left with on the left is, I'm going to go ahead and distribute that y, so I get 3xy minus 2y is equal to, on this side over here on the right, everything canceled except for the top, so I have negative 4x minus 1. Now remember, I'm solving for x, so I need to get these two terms that have x's on the same side so that I can deal with them. So I'm going to go ahead and make the left-hand side my x side. So I'm going to move my 4x over so that it's with this x term. And with that being said, I'm going to go ahead and get rid of my 2y because it does not have an x, so I'm going to move it to the other side by adding. So I'm going to add 2y. So what I have now is 3xy plus 4x is equal to negative 1 plus 2y. Okay. Again, we're looking to solve for x. And right now, I can't just combine these two x terms because one has a y and one doesn't. So the only way I can get those x's out of two terms and into one place is by factoring it out like a greatest common factor. So that's what I'm going to go ahead and do. I'm going to move up here just a little bit, and I'm going to take that x out. When I take that x out, it leaves me with 3y plus 4. And on the right-hand side, I still have my negative 1 plus 2y. Now to get x by itself, I just need to get rid of that quantity that I no longer need. Because it's being multiplied, I get rid of it by dividing. Okay. So I'm going to divide both sides by 3y plus 4, which means that x is equal to negative 1 plus 2y all over 3y plus 4. And I just leave it like that. Okay. All right. So there are, two for y'all to try. I'll give you a minute to work on those, and then we'll go over them. Okay. All right. So on this first one, I started off by going ahead and taking this s and distributing it in. If you didn't distribute the s in, you'll still get the same answer. It's just 9 times out of 10, my students always distribute that in, so that's the way I'm going to show it worked out. So when you distribute that s in, you get sp minus 2sl equals 4. And we're solving for L. So we want to get this L isolated all by itself. So I need to move the term that doesn't have an L to the other side. So I subtract the SP, okay? And then to get L by itself, all I have to do is divide off the coefficient that I don't need, which is negative 2s. Now, the thing about math is we never like negative numbers on the bottom of a fraction. We always move that negative out front, or we distribute it to the top, or we break it apart. We just never leave it on the bottom. So what I did is when I took this right-hand side, 4 minus SP all over negative 2s, I went ahead and just broke it up into two terms. 4 over negative 2s minus SP over negative 2s. And then you can just change your signs and reduce. So on the first one, I reduced 4 and 2, put the negative on top. On the second term, I reduced my s's, and my two negatives made that term positive. Okay? All right, on the second one, I started off by clearing fractions. So we need to multiply both sides by 4x minus 1. When I do that, it cancels on the right. On the left, I go ahead and distribute it out. Now, once I get it all distributed out, notice my x's are not on the same side of the equal sign. So I need to get all my x terms on one side, everything that doesn't have an x in it to the other side. So once I get down here where I have all my x's on the same side, then I factor out the x to get it by itself. Once it's factored out, all I have to do is divide off that leftover quantity. Okay? All right, so that is all of section E1.3. So you will now be able to do that homework in my math lab. Let me know if you have any questions. Okay?